All right. Good morning, everyone. Welcome back to Math 154, week 4, lecture 1 on this beautiful February 2nd, Groundhog Day. As usual, going to cover this whiteboard really quickly, and then we're going to continue where we left off in 2.1, talking about using tables for proportions, aka proportion tables. Friendly reminder to practice with Excel over and over and over and over and over. Last time I'm going to say it, don't even have it on the whiteboard anymore. But in particular, to prepare yourself for the next Excel homework, the 1.8 BMI, you should be making an addition or multiplication table. Remember, we demonstrated that in class already. I'm not going to do it again. If you want to see it, go back to the YouTube videos and find it there. We said that that would be great practice because you can predict the answers for one of these two types of tables. So that way, if you make a mistake using your fixed cell references, you can learn how to correct it. I suggest that you make this table 4 or 5 or 6 times until you feel super confident in it, because when you go to make the BMI table, you're not going to know the answers very well. You're not going to know the answers very well. So, not going to be as easy for you to know that, oh, I made a mistake with I put a fixed cell, or sorry, I fixed the column instead of the row, or vice versa, or I fixed everything instead of just one. Now, remember that in your guided activities, each of the Excel homeworks we do does have something referencing that in the guided activities, not necessarily telling you what to do, but some questions that might maybe push you in the right direction. Also, a lot of times there's pictures that might be helpful. Maybe it spoils some of the answers. Maybe some of those numbers are actually in the guided activities. So if you cross-reference that, that would be a good self-check potentially. I'm not saying it is, I'm not saying it isn't. A lot of the times charts will be in those guided activities. Now remember, you're not responsible for the guided activities having to do with Excels. They're just there to help you if you need the help. Mymathlab 1.1, I'm sorry, 1.2 and 1.3 are due today. 1.1 was already due. 2.1, we're going to finish 2.1 today, and that is going to be due on the 9th then, a week from today. We are actually going to end class a little early today. For section 2.2, I don't like splitting that one up. It's kind of awkward to do so. So we'll just end after about, I don't know, an hour or so today. And then when we come back next time, we'll dive headfirst into 2.2. That way we can finish it in one go. 2.2 is going to be an awesome section with an awesome formula that you'll have to memorize for your tests. And it will be a great formula to use for calculating your own grades in here. And I mentioned that at the beginning of the semester that I was going to be emailing out or distributing on Canvas, one or the other, or both, an Excel grade sheet calculator for you to keep track of your grades all on your own. You will not ask me how to do any how to do that or how to keep track of everything. We will tell you how to do that in here, but then I'm not going to go and say, oh, you can't email me later and say, well, Mr. Beckner, what do I type in here? What do I type in there? I'm like, we talked about this already. You'll get your 10 bonus points for your Excel homeworks and your Mymathlab homeworks, as long as you don't go over 100. But again, Mymathlab grade lies to you. Canvas grade lies to you. You'll need to keep track of these yourself. TV loan, Excel 1.3, we assigned that last time, so that's due on the 7th. Remember, you're getting 5 attempts now on these homeworks. The next Excel, which I said the due date is TBD, but if you want any spoilers, I did already set that up in Mymathlab, but I'll give you that due date next time. And you could probably predict when the due date is going to be, since I've been assigning things 1 week at a time once I give you the due date. So use some logic and reasoning there. But again, it is in Mymathlab if you want a little sneak peek. And that is the Excel homework. We said that the addition and multiplication table creation on your own from a blank file would be helpful. Remember, when you're doing these Excel homeworks, you are not supposed to be starting from a blank file. You are supposed to use the pre-formatted file that they give you. A couple of students have emailed me wondering why they're getting zeros when they feel like they have correct answers. And that's generally what happens. They have created their own brand new file, and then the auto grader doesn't know what to do with that. And I'm not going to override auto grade issues unless it's something that is actually a problem. And that's not a problem. That's on you, not on the grader. There is one homework about halfway through the semester where in my grade book, things will be a little better than what it says for you. And I've pointed this out to the Mymathlab people a couple times and they still haven't fixed it. At least they hadn't as of last semester. Maybe they have now. We'll find out. I'll find out when we get there. All right, video quiz 1. So we have our second quiz assigned, and this is going to be our first video-based quiz. This is not going to be based on videos that I've created. This is not going to be based on videos that I've lectured on. These are going to be based on videos from Mymathlab. We talked about this the first day of class from the resource section, and I'll show you again where that is. So there's a location to download the file, which you can't submit it there. It's only a download spot, and a location to submit it. So when you go into Canvas, you will now see two new files under quizzes. One that says download video quiz 1 and one that says submit video quiz 1. And the one that says submit is where the due date is. So you will have to submit an electronic file, whether it's a Word file or a picture of your handwritten answers, however you want to do it. And then I will have to grade these at some point, usually a couple days after they've been due. I know some people get impatient with me because, oh, why didn't you just grade it immediately? Why didn't you grade it the next day? Well, I tend to have students that might have COVID or something like that, and I have to grant extensions, and I don't want to grade some people's, but not everyone. So that's why grades for these quizzes tend to come a few days later, sometimes up to a week later, in fact. And I don't like when that happens, but again, I don't want to give out quiz scores to people and with other people still having needed to take it. I just feel like that would be a disservice and might lead to cheating. We don't want that. All right, so how are you going to answer these questions? And it's always 4 or 5 questions. You're going to answer in a paragraph or a sentence or a couple of words. I'm not going to be grading you on your phrasing, but do not verbatim copy what the author says. That is plagiarism, and I can give you zeros for plagiarism. I can submit this to a review council, and I don't want to have to do any of that. You need to be putting these things in your own words. I don't care if you're just changing a couple of words, but do not copy paste exactly what the author says. Change something. Make sure you understand what it is he is saying and you are recreating. So where are these video quizzes? Where do you submit them? Okay. Well, first of all, where are the videos? When you're in Mymathlab, you go to the video and resource library, which is right here. And then this is going to be based on maybe chapter 0, maybe chapter 1, maybe chapter 2. I'm not going to spoil it yet. We'll see it in a few minutes. It's on chapter 1, actually. So we go to an excellent approach to relationships, or we could have just left it as all chapters, honestly, but I'm just going to put it on chapter 1. Or maybe it's chapter 0. No, I think it is chapter 0. And then you go to the section if you wanted to. I honestly don't suggest that you do that. For the media type, just click video and then find now, and you'll pull up a whole bunch of videos. Spreadsheet tutorial, spreadsheet tutorial, spreadsheet tutorial, spreadsheet tutorial, blah, 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 spreadsheet basics. These are all titled very well. Oh my Lord, how do I know which video to choose? I tell you in each question which video to choose. So don't worry about that. So if we had a video quiz on chapter 1, there's less videos. Make sure the video is clicked, find now. And it's only about 10 or 12 of them because I don't use the PKA videos. Those are for my MDE students. Okay, so that's where we find the videos. Where do we download? Where do we submit? Well, we go to our Canvas. We go to our course. We go to quizzes. Let me make sure student view is up so you don't see everything. And then here are the 2 new files, video quiz 2, downloaded here. So you can click that. And you can see your 4 questions for this one. And when it's actually based on a video, the first one is just describing how to get the videos to this course, which is what I just showed you. If you answer how to get to the videos I created for this, you will get no points, okay? Describe how to get to the videos for this course. What I mean here is the videos for this quiz. I know I didn't phrase that very well, but you have to watch the lecture videos. You have to watch the lectures. So that's what I mean. I am talking about how do you get to the videos for the quizzes, okay? Make sure you understand that. So you go to Mymathlab, you go to the video resource library, et cetera, et cetera. That's what you should be answering. Spoiler alert. Number 2, 3, and 4 are actually based on videos, and you can see, oh, spreadsheet tutorial video, spreadsheet tutorial video fill formula, spreadsheet tutorial video fill formula. I didn't finish reading this one. Formatting cells with percent style. So that tells you exactly where to go. So these are based on chapter 0. So chapter 0 is what these are based on. Later, I'll actually say which chapter they're on, but for now, I just say, just keeping it general. It's the first one, so chapter 0. Then, after you save your file, you will go here to quiz 2, submit video quiz 1 here, due date February 9th. And then you'll have to hit start assignment. Then you can upload your file, and then you will submit your assignment. And again, this is not auto-graded. I will have to go back and grade these maybe a day after they're due, maybe 2 days after they're due, maybe 5 days after they're due, depending on when everybody has submitted them that has, maybe said, hey, I'm sick and I have a legit excuse and a doctor's note and et cetera, et cetera. If you just say, hey, I forgot to do it, that's not going to fly. I would need documentation as to why you've missed an assignment. Remember that. Okay. So there will be several of these video quizzes throughout the semester. There's going to be about 4 or 5 of them, and they're going to come, a little more stacked in the beginning. Then we're not going to have any for a while, and then they're going to cap in boom, 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 boom at the very end. We will still be talking about guided activity stuff today, which the discussion boards are based off of, but I'm not assigning any discussion board today. But make sure that you can follow along the guided activities from the notes every single day, even if I don't assign a discussion board. You should be writing things down. You should be following and understanding. All right, so with that being said, let's go ahead and pick up where we left off in 2.1. Like I said, we were working with the proportion table. We had seen that big proportion table with lots of blanks, and we only had 1 or 2 spots that we could actually fill out. That's where we left off. So let's pick up.
We had done this. We talked about how we can use proportion or ratio tables to find out anything as long as we know that the table is set up in a proportional manner. Just because you have a table of numbers doesn't mean it's proportional. Someone has to tell you that, or you have to establish it based on patterns and things like that. And the main pattern is whenever one thing doubles, the other doubles. You could say it as one triples, the other triples, as one quadruples, the other quadruples, but proportional means a constant multiplier between them. Just like 2 apples triples to 6 apples, the 3 oranges triple to 9 oranges. If it may be on Wednesday, there were 10 apples sold, that means they sold 5 times as many apples, which means they'd sell 5 times as many oranges. Now, does a store's apples and orange sales have to be proportional in the real world? Absolutely not. They could actually be what's known as inversely proportional if maybe there's a sale on one of these things, so people are going to buy way more apples than oranges, or vice versa, whichever one's on sale. So again, in the real world, you might have to put your brain cells together and figure out whether they are proportional or not, and then extrapolate from there. But we said the wonderful thing about a proportion table is that they don't have to be all just sitting next to each other to set up the fraction equal to a fraction and cross multiply. There can be giant gaps between them, and very often they are in the problems that we have to do. But it doesn't matter. You don't need any of the numbers in between as long as you can imagine yourself drawing a box around some numbers. And when you do that, you have 3 corners of numbers and a blank. And it doesn't have to be the bottom right blank. There could be a number here and the top left is blank. You just set fraction equal to a fraction. We've discussed the 10 different ways. I mean, a rounded number, the 8 different ways you could set it up. It could have been 2 over 3 equals 6 over x. It could have been 2 over 6 equals 3 over x. It could have been 6 over 2 equals x over 3. It could have been 6 over x equals 2 over 3. It could have been x over 3 equals 6 over 2. It could have been x over 6 equals 3 over 2. I mean, I don't even know how many ways I just said in that lightning bolt amount of time. But all of those would have led to the same answer of x equals 9, which in this table, it was limes on Friday. Whereas before, the smaller table, different fruits, different days, just to prove a point. Again, you will see this over and over in this course, especially with something called a consumer price index. We'll get into that later. So what we did from there is we pulled up our guided worksheet, and we were talking about how, okay, we have some births based on a population. We said maybe we shouldn't base it off of the whole population, maybe just the number of women in birthing age. We wanted to find out how many births there would be if there was only a population of 1,000 people. This is scaling. It's not scaling to 1, it's scaling to 1,000. We could also say that there's 60.2 births for every 1,000 women of birthing age. So that's another scaling. You can use that idea to go back and find out how many birthing aged women there are. what we did together last time was we used these simpler numbers of 4, 8, 12, 8 ended up being there, 500, 1,000, and etc. Whatever number that happens to be. Whatever off the top of my head, that's okay. So what we're going to do this time is use the more legit numbers with these ugly decimals, etc., etc. Not decimals, just millions and millions, and we'll have decimal numbers. They say to round to 2 decimal places. Remember, you have to pay attention to this. Mymathlab marks things wrong when you round wrong. Round to 1 decimal, it's wrong. You round to 3 decimals, it's wrong. Maybe on a test, if you showed some work and mentioned it to me, I can give you partial credit. So I said maybe. If you didn't show your work, no partial credit. Now, do you have to have an entire page of work to get partial credit? No, I just have to see something. Otherwise, I can't say, well, you didn't prove that you actually figured this out in any way, shape, or form, so maybe just pull the answer off the internet. I don't know. That's not the point of quantitative reasoning. You can use the internet as a resource, but not to do the answer. Okay, so this is in a proportion table. They said everything was based on proportions, so our goal is to find the B and the W. And they give you some space to fill out the work. I don't like using the annotation that way, as you have seen multiple times. So let's just do the work over here. Now, move this a little more, because I can't see all the numbers. Good enough. Numbers and variables, that is to say. So they called B for births. Now this B is specifically representing when the population is 1,000. So this B is the number of births per 1,000 people. 1,000 people. And the W would be the number of women of birthing age and the total population. So you've got to pay attention to your rows and columns and how things set up. Everything is relative. This B isn't based on the whole population. It's based on if the population was only 1,000. So it's scaled. So we talked about how scaling things to 1 or 100 or 1,000 can give us sometimes prettier numbers, sometimes easier numbers to relate to. Like if you scale something to 100, you can think of it as a percentage. Population things are very often scaled to 1,000, just to kind of eliminate 3 places, if you will. Yeah. So imagine yourself drawing a box in such a way that you'll have 3 numbers and a variable in the corners. So just really quickly, if you do like this is not going to solve for the B. First of all, the B isn't in a corner. And you got 3 numbers in corners, it would actually solve for this right here. If you use this number, and this number, you could go 3.8 million over 60.2 equals 324 million over X. But I was not asked to find the population if there's only 1,000 women of birthing age. So again, scaling down the population. We weren't asked to find that. Don't find that. Can you find it? Yes. Would you have maybe a job that makes you find all of these blanks? Maybe. Is that our goal? No. We're only finding these 2 specific things. The number of births per 1,000 people and the number of women of birthing age. So don't do more than you have to. We're just going to do this as our box. So the 3.8 million over the B equals the 324 million over the 1,000. All right, so 3, and I'm going to abbreviate, come on, don't do this to me today, 3.8 million over the B is equal to the 324 million. Now, when I do my calculator, I will write the numbers in appropriately. You cross multiply, so you'll get 3.8 million times 1,000 is equal to 324 million times the B. Again, the M's are abbreviations for millions. Don't think they're variables, please. 3.8 million times 1,000 is just going to make that billions, so it's now 3.8 billion. I'll write the word because there's another B. So in other words, it's just 3 more zeros on this number right here, 472, 000. That'll be equal to the 324 million number times the B. How do you solve that very simple equation? You divide both sides by the number with the variable, 324 million. And that tells us that B is equal to, let's pull out our calculator. So 3 8, 5. Let me clear all that stuff. That was from my other class earlier. 3, 8, 5, 3, 4, 3, 8, 5, 3, 4, 7, 2, 0, 0, 0, divided by that 324 million number, which is 324, 459, 463. And we get 11.87, blah, 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 blah. We're rounding to 2 decimals, so 11.88. Don't forget, when quantitative reasoning, make sure you understand what exactly you're answering. Don't just give this number. This is not the answer. The answer is, so it's 11.88 births, because that's where we were births, and then it's based on a population of 1,000 people per 1,000 people. That's what's happening there. That's what that number means. It's 3.8 million births for 324 million in population. It's about 12 births per 1,000 people in population. If our births was 60.2, again, we could figure out what that X was some way, shape, or form. I've already described, but we weren't asked to. It's not really an important number, so we don't. The next thing we were tasked with finding was this W. So if we try and draw a box, now you could certainly do this. I'm going to say I'm not going to, but you could. You could draw your box this way, because then you've got number. We now know this number. Wait, we don't know that number over there. Excuse me, I'm thinking that I had the number there. So we can't. I'm going to say that didn't make sense to myself like we do with quantitative reasoning. I caught myself and I said, there's no number here, there's no number here. So that's 2 numbers and 2 blanks. But the point of me bringing this up was, this right here, this B, was rounded. So this 11.88 is a rounded number. If you use a rounded number to find another one in a proportion table, this is going to have something called error truncation or error propagation. You use a number that's been rounded to find another answer, and then round that, and then use that to find another answer, and then round that. These rounding errors end up causing bigger errors down the line. So maybe this answer is supposed to be, let's just say it was 12.5. That's completely wrong, but it's supposed to be 12.5. But with your number, you get 12.6. Mymathlab might mark it wrong, and that's because you used borrowed information to move along. So my suggestion is to try and only use, when you can, the numbers prescribed to you. I guess I could have just hit clear. There we go. So we know this is the end of it, so I got to draw the box that way. Now you might say, okay, can I do it this way? Can I do it this way? Can I do it this way? Well, no. Number, number, blank, blank. So that fails. Clear. Maybe we need to go down all the way. Could I do it like this? No, because there's a blank here and a blank here, so that fails. But if you do it across the whole entire table, excluding labels, remember labels are not numbers in a proportion table, they're just labels. We got number, 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 and the variable. So there is what we need to draw up. All right, but I do have to clear that. Come off of annotate. Scroll down. So that would be, I'll do it in a different color. We'll do black this time. 3.8, the million number, over the 60.2. Remember, it's this number over this one. This is the easiest setup in my opinion, equals the W over 1,000. We cross multiply. We'll get the 3.8 million times the 1,000 equal to 60.2 times the W, which is 3.8 billion equal to the 60.2 times the number of women of birthing age. Divide both sides by 60.2. If you can't do this very simple algebra, you have got to practice it 1,000 times before you can. And then do the calculation. So the 3, 8, 5, 3, 4, 7, 2. And then there was the 3 more zeros from multiplying it by 1,000. And we're dividing it by 60.2. And we get 6401162.79. Now, they said to round it to the nearest 2 decimal places, so that says that W is equal to 6, wrong color, 6401162.79. Actually, our calculator, because it can only handle so many numbers, went ahead and rounded it to 2 decimal places for us. But what exactly is this? This is women of birthing age. Now, very often when we're talking about a large number of people, we don't really like decimals. If we're talking about a couple of people, like, hey, the average household is 4.2 people or something like that, that's when we'll leave a decimal with people. But it's really hard to have 79 100ths of a person. So the rule of large numbers kind of states that you just round that to the nearest whole instead. So 640111163, which would be 64,011,163. I knew my comma placement wasn't perfect there. Let me just rewrite the number. I can do better than that. 64,011,163 women of birthing age. That's the answer. It's not 64 million people, 64 million women of birthing age. Remember, you're supposed to be doing these and then asking yourself if it makes sense. Well, if the population is 324 million, does it make sense there's about 64 million women of birthing age? Well, about half the population is women, so half of 320 million is about 160 million. And there are women younger than 15. And the biggest portion of the population is the people under 21. So there's a lot of women under 15, girls, whatever you want to call them. I don't care about labels. And then there's a decent amount of women over 44 as well. So I'd say this is a pretty good ballpark answer. What do I mean by does it make sense? How do I really say this number makes sense? What if I forgot to multiply by those zeros and I said the answer was 64,011? What's going on? If I said the answer was 64,011 women of birthing age, would that make sense? Well, if there's 324 million people we're discussing this relative to, I don't think 64,000 women of those people are able to give birth. It's way more than that. That answer would not make sense. Or maybe I had too many places. Maybe I said that there were 640 million women. How would there be 324 people on the world, or in our country, excuse me, in our country? How would there be 324 million people in total, but there's 640 million women able to give birth? That's more than the population. That wouldn't make sense. You have got to learn to do that after every single answer of anything in a quantitative reasoning sense, which is pretty much the entirety of this class. All right, so next up, what we're going to do is that far enough over? Yeah, that's far enough over. Okay. So the next thing we're going to do is we're going to talk about college tuition, because what do we all pay, or someone pays for us? College tuition, right? So they have a column for private four-year schools, which are historically the most expensive. They have a column for public four-year schools, traditionally the in-between. And then they have a column for the public two-year school. So the left is our private schools, oh man, what is the local one? I'm blanking. Let me come back to it. Then we have our public schools like ODU, Virginia Wesleyan. There we go. Now I remember. So private four-year, this is kind of like our Virginia Wesleyan, but averaged across all of them. This middle one's like our ODUs and our Norfolk States and our VCUs and our Virginia Techs and UVAs. Then this right column is our TCCs and our Thomas Nelsons and all the other ones like that. So our community colleges are the cheapest by far. Our ODUs and CNUs in Norfolk States are kind of middle of the road. And our private schools that are not governmentally funded. So since Uncle Sam's not helping with the bill, you got to pay the whole thing, $30,000. So they're saying these were the average tuition and fees across a whole bunch of different places. In 2013 and 14, these numbers have gone way up, like tuition does. But that's okay. Old numbers are fine to understand. So what's going on with this table? What's this 1 right here? What's this 100 right here? What's this 1 right here? Ignore this multiply bit for a second. I've already alluded to that earlier when I was talking about apples and oranges. All right, 2 apples on Monday, and then it's 10 apples on Wednesday. So that was a multiplier of 5. So if you have 3 oranges on Monday, that means the other day you multiply that by 5. Basically, it's the ratio between some stuff. Okay, so this 100 is like scaling the private four-year to a percent. So if 100%, if you're paying 100% to go to a private four-year, what percentage of that are you paying to instead go to ODU or CNU? What kind of answer would you expect? Probably something in the double digits, like 15%, 30%. You wouldn't expect it to be 5%. You wouldn't expect it to be more than 100%. The fact that this number right here is bigger than this number here should be true across the entire columns. The fact that the 8893 is bigger than the 3264 should be true across the entire columns. All of these numbers in the first column should be the biggest, all the numbers in the middle should be in the middle, and all the numbers on the right should be the smallest. Now, that's just based on how I set this up, or how they set it up. If you swap all the public and private four-year numbers, then the biggest ones would be on the right, smallest on the left. Okay, so scaling this to 100, the private four-year, that'll be like us saying, all right, well, what percentage are you paying in comparison to a private four-year to go to ODU? Maybe like 20%. What percentage are you paying to go to TCC? Maybe like 10%. Scaling things to 1 is like, okay, for every $1 you spend in a public four-year school, how many dollars do you spend going at a private, if you wanted to go to a private four-year school instead? And you would expect that to be more. Every $1 you spend here is going to be $3 or $4 or $5 or $10 here because of the 9,000 versus 30,000. On the contrary, for every dollar you spend at your ODU, you're going to expect to spend less than $1 for TCC. So these are the things you should be saying or going through with the does it make sense aspect. If I got an answer right here that was 5, it would not make sense because that would say for every dollar I spend at ODU, I would instead be spending $5 at TCC. No, sir, no, ma'am. If it's $1 at ODU, I should be spending, I don't know, 30 cents, 40 cents, 10 cents, 20 cents, somewhere in the cents ballpark. And again, that's for every dollar. So down here, this says for every dollar you pay going to TCC, if you wanted the same education, how many dollars would it cost to go to ODU? Again, $1 at TCC is going to cost you how many dollars instead at ODU? Or if you spend $1 at TCC, how many dollars would you be spending at Virginia Wesleyan? These ones are really awesome for the multiplier effect. For example, let's just say, I'm making this up. Let's say it turned out to be for every $1 you spend at TCC, it's $5. Again, this is wrong. If it was for every $1 you spend at TCC, you would instead spend $5 at ODU. That means that if I spent $100 at TCC, I would instead be spending $500 at ODU. If I spent $1,000 at TCC, that means it would instead cost me $5,000 at ODU. If I spend $10,000 at TCC, it would cost me $50,000 at ODU. So scaling things to 1 is a great way to give us just a multiplying effect. That's what this is alluding to, that will go into greater detail when we have the real answers. So our ultimate goal is to fill out this table completely. We didn't do that last time. We just wanted a couple of the boxes. This time we want everything, the whole shebang. You're not ready for this yet. Let's give us some space. Okay. So fill in the table of values in the ratio table. They tell us it's a ratio table or a proportion table, which is awesome. It means we don't have to prove it. For the greatest accuracy, you should always try to use the original statistics in the first row of numbers in the table. This is what I alluded to earlier with accuracy. So when I get this answer of, say, about 3.5, spoilers alerts, all the plurals, spoiler alerts. When I get about 3.5 here, if I don't have to, I don't want to use that number to find this blank, this blank, this blank, this blank, or this blank. I want to try and only use the 1, 2, 3, 4, 5, 6 numbers they gave us. Maybe you can't, maybe you can, but that's your first effort. Okay, the order of the blanks you tackle these doesn't really matter. I'm going to tackle them in this order. I'm going to find, and I'm going to label them A, B, C, D, E, and F. Please work. Did that work? It did, okay. So I'm going to try and find A first. Remember, you're trying to draw a box. And I'm not going to actually literally draw the box every single time. It's going to get tedious. This was going to be a guided activity for y'all, but there's only 6 answers and I got a lot of students, so it's okay. I want to go through it together. So we take the 30,000 over the A and set it equal to the 8893 over the 1. Again, this is my box. 3 corners have numbers, 1 has a blank. Can you see that? I hope you can see that. I'm circling around these 4 spots. So we're going 30,094 over A equals 8893 over 1. Remember, there's arguably 16 different ways I can write this proportion with those 4 values and variables and still get the answer right in the end. There's also plenty of ways we can write it wrong. My favorite is top over bottom equals top over bottom. Cross multiply. I'm not going to show every single step. 30,094 times 1 is 30,094 equals 8893 times A. 8893 times A. Divide both sides by the number with the variable. Divide by 8893. And we ultimately get, calculator, I don't know why I have to do that sometimes. It's clear, 30,094 divided by 8893. 3.38, blah, 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 blah. Now they know where it told us how many places to round to. You can choose to round to 2, you can choose to round to 1, it's up to you. Sorry for the little ink over there, I just don't want to remove those. I'm going to round to 1 decimal place for this one. You could certainly round to 2. Because I didn't tell you where to round, you could round to 2, you could round to 3. I'm going to choose 1 for this one. So that's 3. I hate that it does that when I go back to Word. 3.4 is equal to A. So that's a 3.4. Now, again, I could use that number to find a couple other spots, but I'm going to avoid it if I can. Now let's try and find B. Can we imagine ourselves drawing a box around B in some manner? Well, you're not going to be able to do it down here in any way because these are all blanks pretty much. So you're going to have to go above it. So maybe the whole thing, could you do it this way? You certainly could. If I go around all 6 of these values, I'd be using the 30,000, the A, the 3,200, and the B. But that uses a borrowed number, a rounded number, and I suggested that we try not to do that. So while it does work, you'll get a close answer. It won't be exactly the same as what I'm about to do. So I'm going to draw my box this way. I still have 3 numbers in corners and an unknown. So I'm going to go 8893 over 1 is equal to 3264 over B. Again, this is the box. These 4 right here, all snug next to each other. Cross multiply, you get 8893B equals 1 times anything is the anything, so 3264. Divide both sides by the 8893. To tell us that B is equal to 3264, 3264 divided by 8893. And we get 0.367. Now, because this number is not a whole, you might say, well, you rounded the first one to 1 decimal place, so 0.4, and that's okay. It's not bad. But because this number doesn't have any holes to it, I'm going to be very loose in how I round. Even though I rounded the last one to 1 place, I'm going to round this one to 2. Does that mean you have to know to do that? No. You can call that 0.4, but I just feel like this gives it a little more accuracy. And you might say, all right, well, since I rounded that one to 2, maybe you go back and round the previous one and you call this 3.38. Again, that is perfectly fine in the real world. All right, let me try and not use too much space. So that was B. Do these answers make sense? Okay, for every $1 you spend at ODU, that means we would be spending A, $3.4 at Virginia Wesleyan at a private university. I think that makes sense. It's a 3.4 multiplier. So if you spent $1,000 at TCC, that means you'd be spending $3,400 at Virginia Wesleyan. If you spent $10,000 at TCC, you'd be spending $34,000 at Virginia Wesleyan. That's the convenience of scaling to 1. How about B? For every dollar you spend at ODU, you would spend 37 cents at TCC. Again, that makes sense. You should be spending less than what you're spending at ODU. All right, let's try and get C. I'm going to skip drawing a million fake boxes just in the interest of time. But again, try and practice this on your own. After you see these answers, go back and try and replicate them. Don't just listen to me and say, this is how I drew the box. Figure it out on your own. Okay, so this discussion board, this group work is just going to be independent, and I'm not going to ask for the answers because I want every single one of you to do this, not just 6 of you. So C, if we do the box like this, that would be not good because we'd have 2 blanks. We'd be using C and D. So how about this? There we go. The 30,000, the 8,800, the 100, and the C. We're ignoring the A and the 1 row. We're going corners. 30,000, 8,800, 100, and the C. So 30,094 over 100 is equal to 8,893 over C. Cross multiply, you'll get 30,094 times C is equal to 100 times 8,893. Just tack on 2 zeros, 8,89300. Divide both sides by the 30,094. Make sure you're doing your algebra correctly. Again, you are supposed to be experts of algebra at this level, not crazy algebra experts, just the simple stuff. And yes, this is simple stuff. Do your math. So 889300 divided by 30094. And we get 29.55. It's got a hole, someone around it to 1 decimal, 29.6. So this is your 29.6. So that says for every $100 you spent at Virginia Wesleyan, you're only spending $29.6 at ODU. That's one way you can think of it. But the way I prefer to think about it when you're talking about scaling to 100 is a percentage. So if you're calling the private school 100%, that says that ODU only costs you 29.6% in comparison to Virginia Wesleyan. That's what that says. So because this was 100, that's calling 100% the Virginia Wesleyan type school. This says that ODU type schools would cost 29.6% of that. D will be a similar type answer. And I'm going to draw my box this way. I hope you can see that. Around the 30,000, the 3,200, the 100, and the D. Yes, I could draw it this way using the C and D, but then I'm borrowing a rounded number, which would give slightly different answers. So again, 30,000 over 100 equals the 3,200 over the D. 30,094 over the 100 equals the 3,264 over the D. Cross multiply, 30,094D equals 326400. Divide, I'm going to skip showing all that work and just do it in the calculator. So we get 326400 divided by 30094. And we end up with D equals 10.8. Again, rounding to 1 because of the holes. D equals 10.8. So does it make sense? Well, I hope so. If 100% is the private school, 29.6% is ODU, 10.8% is TCC. So TCC costs 10.8% as much as a private school. Again, if those were the actual numbers, which are not, these are averages. E and F, very similar. To get E, I'm going to draw a box around this whole thing. So the numbers I'll use, the corners are the 30,000, the 3,200, the E box, and the 1. Whoops, I didn't mean to click that. Uh-oh. Uh-oh. Oh, that's just silly. Now they're not going to be in the right place. I'm not erasing that and rewriting it. You know where the boxes are. Sorry about that. My calculator back up. I didn't mean to click something is what had happened there. So the 30,000 94 over box E equals the 3264 over the 1. So now we're saying for every dollar we spend at TCC, how many dollars would we be spending at the private school? Cross multiply, we get 30,094 equals 3264E. Divide both sides by the 3264. 30,094, oops, went too far. Divided by 3264. And we get our answer. The E, does that look right? I did this intentionally wrong, believe it or not. 92. So we're saying for every $1 we spend at TCC, we're spending almost 100 at that. That doesn't seem to fit the rest of the bill. I mean, it is bigger, but it seems like we made a mistake somewhere. And it wasn't in the algebra over here. It was in the calculator use. I hit 0 one too many times. So let's try again. 30,094, not 300,094. There we go. Divided by 3264. But if you don't pay attention, if you don't ask yourself these questions, you're going to assume it's right because your calculator said it, and you're going to get it wrong. So 9. Shouldn't say hate. 9.2. I dislike equals E. Hate's a strong word. So for every dollar we spend at TCC, we're spending about $9 at the private school. That seems to fit the bill a little more. 3,000 versus 30,000. That's about a multiplier of 10 to go from one to the other. So 1 to 9.2 is a multiplier of about 10. All right, finally, to get F, I'm going to draw my box in this way. And again, you don't have to literally draw the boxes. It's just visualizing them ultimately. 8893, the 3264, the F, and the 1. So 8893 over the F equals the 3264 over the 1. Scaling things to 1 is also awesome in the proportions because it's just 8893 equals 3264 F. Divide by the 3264. Spoilers, I'm going to do this wrong. I'm going to divide wrong. I'm going to do 3264 divided by 8893. And I get 0.367. So that says for every dollar I spend at TCC, I'm spending 37 cents at ODU. That doesn't make sense because ODU is more costly. Oh, I goofed my algebra. Instead of dividing by the 3264, I divided by the 8893. So let's fix that. We asked ourselves if it made sense. We checked our work. We didn't just trust a calculator blindly like so many people of the world. Trusting data blindly, just trusting computers blindly. 2.72 or 2.7, since it is a whole, it has a whole number in it. And again, I chose to round in this way. I would never care if I don't tell you how to round in a test. I would not have a preference, but your tests will tell you to round. This is not a test style question where you have to figure out how to round. This is a real life scenario where you just kind of choose the level of accuracy. You could have chosen 2 decimals for all of them. You could have chosen 1 decimal for all of them. You could have gone to 3 decimals. Whole number, a little too much rounding for some of them in my opinion, but you certainly could have. And that of course was F. So does that make sense? For every dollar we spend at TCC, we're spending about 2.7 at ODU. Yeah, I think that makes sense. These things are about a 3 times multiplier. This is about a 3 times multiplier. All right, let's clear our screen. Go off of annotate. Question 6 refers to that multiply thing I was talking about, going from here to here. Multiply by what? So how would you go from here to here, just doing a multiplier and not cross multiplying? Because cross multiplying is one way to solve proportions and to do things, but when you scale to 1, you don't necessarily have to cross multiply and all that jazz. You don't necessarily have to set up a proportion. You can use that, oh, okay, well, we went from 2 apples to 10 apples, that's 5 times as many. So if we have 3 oranges, I'd expect 5 times as many oranges. 3 times 5 is 15. You can use that concept. So question 6, what number do you multiply by? I'm going to put the annotate on for this, to go from the values in the second row to the third row. So we're trying to go from here to here. So multiply by what? Where the numbers we had in place were, this was a 3.4, this was a 9.2, this was a 29.6, I had to write this down, this was a 2.7, 0.37 and 10.8. 10.8. This idea of multiplying by is all centered around the 1. That's your anchor. So we're going from row 2 to row 3, row 2 to row 3. So you find the 1 in row 2, and you find out what value it turns into. It turns into a 29.6. That is your multiplier. This right here is the multiplier, the number that the 1 references to. Now, if I said if we were trying to go from column 2 to column 3, that would not be the multiplier. We'd be going this way from the 1 to the 0.37 instead. So we have to pay attention to what they asked. So we multiply by 29.6 to get row 3 values. So instead of doing all those proportions and stuff to find the 29.6 and the 10.8, check this out. Let me take it off of annotate. Pull up my calculator. You don't trust me. Why am I still on annotate? I said off of annotate, you silly goose. So this 3.4, I'm saying if you multiply that by 29.6, you'll get 100. At least close, 3.4 times 29.6. That there was rounding involved, so it might not be exact, but that's freaking close to 100. This 0.37, if you multiply it by 29.6, 0.37 times 29.6. 10.95, 10.8, really close, so that's a good quantitative idea. So when we have a 1, it's really nice in terms of the actual application of saying, all right, for every dollar we spend here, this is how much is spent here, this is how much is spent here. But it's also amazing for filling out other parts of a proportion table without cross-multiplying and solving, cross-multiplying and solving. Now, again, are these answers exact? No. Are they good enough in terms of rounding in real world? Yeah, sure. How could we have made them more exact? Have more decimal places. Okay, so what about the other part? How do we go from the third column to the first column? How do we go from the third column to the first column? Well, the third column is this column. There's a 1 in it, which is right here. Back to annotate. So we're starting in the third column and we're going to the first column. So this 1 points to the 9.2, which is that's the multiplier. So that's the second part. So from the third column to the first column, that's what I'm answering now. You would multiply by 9.2. So to have gotten the 3.4 or the 100, if that was a blank, you can just multiply anything in the third column by 9.2 to get the first column. Don't trust me? Oh, I know why. I just figured that out. I got to remember that, why I kept accidentally coming back to annotate. So let's take the 10.8 times 9.2. And again, both of these are rounded values, so it's not going to be exactly 100, but it's close. If you take the 0.37 and multiply by 9.2, won't be exact, but it's pretty close, 3.4. That one's actually really close. And the closeness is going to vary. I'm not going to talk about the reasoning behind it. But yeah, these are just some awesome things that you can use. Scaling to 1 gives us a way to fill out a proportion table quicker because we won't have to set up proportions. We can just use multipliers. Scaling to 1 is also awesome because it enables us to do that. All right, for every 1 here, how many about over there? How many over there? Scaling things to 100, great for percentages. Pardon my cough. What do I have? About 5 minutes. I don't have enough time to finish that one, which sucks. That's where I wanted to do that, but I don't have time. That's frustrating. Okay, so what I'm going to do is I'm going to make a statement. Let's clear my screen. off of annotate, back to the Word file, not that Word file, the other one, maximize it again. So just kind of a note, you may come back and complete page 6970 together or as a DB discussion board. It shows us writing ratios to 1 or to 100. It takes one of the examples for number 2. It does them in one way. Then in number 3, it flips them to make sure that you're paying attention. So instead of going big number to small number, it asks you to go small number to big number. Question 1 we'll skip. It's not that relevant to what we need to do. But it's just questions 2 and 3 really. 2, 3, and 4, excuse me, that we'll do later. And again, I might do it. It might be a discussion board. We'll see.
All right. So like we said, we finished 2.1. So that homework is going to be due in a week. We already talked about the Excel homeworks on the horizon. Video quiz on the horizon. Nothing really else to say. So when we come back next time, we're going to do 2.2, which is on the weighted average formula. Like I said, that is the formula that you can use to calculate your grade for courses. You can use it for averages of things that have different values, different weights to them, like something is a little more important. So kind of like you might have a class with 2 types of grades, tests and homeworks. Tests are 70%, homeworks 30%. That would be giving something different weights, something more importance. Or maybe you have a class where something counts as 3 assignments instead of 1. That is actually a weight as well. Just about every type of grade can be done that way. You can also use this for calculating average ticket prices or average fruit prices if you're buying fruits of different prices and different quantities. So like you buy 5 apples and 4 oranges, where apples are $1 each and oranges are $1.20 each. If you want to find the average price that you paid per fruit, you'd have to account for the number of fruits you bought as well as the cost per item of each fruit. All right, so like I said, we'll get into that next time. But for now, have a good day. Have a good weekend. We will see you back on Monday the 7th. Take care, everybody. And as always, email me if you have any questions. All right, take care.